Le Chatelier's principle describes what is observed when changes are made to an equilibrium system. It doesn't, however, explain why. And thinking that a position of equilibrium is trying to change is, well, a bit misleading. Positions of equilibrium aren't trying to do anything. Why then does it look like this happens? And why is it important enough to have to study? Remember that it is the rate of the forward and reverse reactions that determine whether a system is at dynamic equilibrium. The rates of both must be the same. If for a system already at equilibrium, the rate of either the forward or reverse reaction is changed, the system would no longer be at equilibrium. And there would be a short period of time where one reaction is happening faster than the other. Eventually, if left long enough, the faster rate would slow down and the two rates would become equal again, and dynamic equilibrium would be reached once more. For example, let's look at an equilibrium system between hydrogen, iodine, and hydrogen iodide. In this system, let's say there is 1 mole of hydrogen, 1 mole of iodine, and 5 moles of hydrogen iodide. As the system is at equilibrium, the rates of both the forward and reverse reactions are the same, meaning these values don't change. Now, say we increase the concentration of hydrogen and iodine in the mixture by adding in another mole of each. Now there would be 2 moles of hydrogen and 2 moles of iodine in the mixture. The rate of a reaction is based on the concentrations of reactants. If we increase the number of moles of hydrogen and iodine then, the rate of the reaction between hydrogen and iodine will increase as a result. The forward reaction in this case. We haven't changed the number of moles of hydrogen iodide, however, meaning the rate of the reverse or backward reaction remains the same as before. The rates of the forward and reverse reactions then are no longer the same. We've broken the dynamic equilibrium. For a short period of time, the forward reaction occurs at a faster rate than the reverse reaction. A new equilibrium will form as the reaction between the hydrogen and iodine starts to slow down as their concentrations decrease a little. Whilst at the same time, as more hydrogen iodide gets formed, the rate of the reverse reaction will start to increase slightly, and bang! At a certain point, both the reaction rates become the same again, and the system will have reached a new dynamic equilibrium. However, if we look at the amounts of hydrogen, iodine, and hydrogen iodide now, there are no longer the 2 moles of hydrogen and iodine that there were immediately after the extra mole of each was added. Whilst reaching this new dynamic equilibrium, more hydrogen and iodine got converted into hydrogen iodide than hydrogen iodide got converted into hydrogen and iodine. This means the concentrations of hydrogen and iodine in the system decreased, and the concentration of hydrogen iodide increased. Products increased in concentration, reactants decreased, meaning we say the position of equilibrium shifted to the right. Le Chatelier's principle. Position of equilibrium moves to oppose a change made to a system at equilibrium. Hopefully that example shows you, however, that the reason this occurred is based solely on rates of reaction. Le Chatelier's principle isn't explaining what's going on at all, it's just describing the observations seen.